Do either of you want to pose a defense of bird brains?
Well, I could start. I
think
we
I
both
know Lauren
would like
wants
to
to.
defend the bird brains. Yeah. So I think historically people thought because birds can fly, they gave up brain power. So they're just feather-brained. And if you look at the bird brain, comparing it to a mammalian brain, it's very smooth. So people thought, yeah, that matches. They're just instinctual, you know. They're not capable of complex thought. And then if you look at some of the structures of the bird brain, they were named things like primitivum or archopallium, as if they're archaic. And actually, Erich, like probably 20-something years ago, led a group to kind of change the bird names so that they would match what we actually know about the bird brain. And so I think what we're seeing is that the bird brain, it is organized differently from a mammalian brain, but there are a lot of the same neurochemicals in the bird brain. It's organized, at least some of the projections are similar to what you might see in a mammal. And then if you look at birds, some of the things they do are so amazing, there's no way it's just instinctual.
Now, tell me, so you described the brain as being smooth. What's the significance of the surface of the brain being smooth compared to human beings, which have a really folded fractal surface?
Yeah, so the idea has been that with a folded cortex like we have in humans, all that folding creates extra surface area that you can fit into a small head, right? Bird brains, they don't have that folding. But what do they do that's different than mammals is that they increase PAC, the density of neurons, a lot more. So birds have 2 times the amount of neurons per cubic millimeter than mammals. And further, parrots and songbirds, the vocal learning birds, have 2 times more. So they have like 4 times the number of neurons than we do in the same amount of space.
Interesting. So human beings, Homo sapiens, they fold it to increase the surface area and fit it in the small cranium.
That's right.
But they have a higher density.
But birds,
so who's the bird brain now?
Yes, yeah. I think bird brain is pretty insulting, right?
Not anymore.
To the birds, right? Yes, that's right. Yes.
Now, the brain obviously is doing a lot of processing. It's trying to take in a lot of sensory information and process it. And birds, we're going to get to the language centers and the auditory processing, but even visually, they're quite interesting. Do birds have a different range of visual experience, for instance, than human beings? And is that part of the body, the eyes, or the brain?
Well, you can imagine flying in 3-dimensional space, way up in the sky. You're going to need a good visual system. And birds have most bird species, particularly the flyers, have very advanced visual systems that can detect all kinds of shapes and so forth. So pigeons, you can teach them to learn like 700 different paintings, and they'll remember them better than humans would. And even different styles like Picasso versus Monet and so forth.
I'm trying to, I don't want to fall down this rabbit hole, but I'm trying to imagine how that study was done.
Yeah, taking a pigeon and having them peck a key to discriminate different paintings on a computer screen.
And then they get food, presumably.
Yes, well, they get food, that's right. Yeah, food reward for getting it right.
And are they seeing in the same visual range like we see predominantly in what is named the optical range, because that's what we see in? Are they seeing in the same visual range that we are?
They're a little bit different. They have 4 cones. We have 3. And so they can see
cells in the eye?
In the retina.
Yeah, in the retina. And so they can see in the UV range that we can't see. So I'll just say it now, and you'll groan if you love birds, but I study European starlings, mostly. I hear it. I know. They're agricultural pests.
I'm glad you just got that over with early.
I just had to get that out, right? But I appreciate their singing behavior, and I think you would too. But they have these collars, and we can see they're kind of pretty purple collars, but I think that if you were a starling, what you see is a beautiful necklace that we just can't see. So they do have, and they have the ability to hear sounds, rapid sounds. So when we hear bird songs, some of us can tell the differences between one song and another, and females are listening to those males and picking mates, and they hear things we can't, because they can hear things that occur really, really quickly. They can hear gaps in the sounds that we can't hear.
And can they also detect magnetic fields? Is that real? Like the Earth's magnetic field and the sun's magnetic field, does that participate in the migratory patterns and their ability to orient themselves? geolocate?
Yeah, I worked with a guy named Henrik Moritzen, where we use our molecular techniques and brain activity techniques to detect a part of the bird brain that's actually sensing magnetic fields that they use to orientate to go in different directions. And the magnetic sensing field part of the brain evolved out of the visual system. And the birds are basically kind of seeing the magnetic field with their vision.
That's exactly what I was going to ask. Whenever I hear something like that, I wonder how they experience it. Because, of course, our qualia isn't, some cell detecting. We have a hallucination of seeing something. So you think that they're effectively seeing the magnetic fields.
Yeah, how much they're perceiving what they're seeing, but you can record in their retina, you can go to a certain brain area up here, and you will see the activity change with the magnetic field change.